Hey guys, so here is our entrance ticket from this morning or this afternoon. I'm gonna go over the entrance ticket and then I'm gonna dive deep into this graph here. That's gonna be part of what we do tomorrow in class. So number one says, what is the vertical intercept also going to be called in my class? The vertical intercept is the y-intercept. The y-intercept is my correct answer. Because the vertical intercept is just the point where it crosses the y-axis. So when it says vertical intercept, it's asking where does it intercept the y-axis. So that's why we call it the y-intercept. And a lot of math teachers, your high school math teachers, will also call it the y-intercept. Okay, two said to name one fun fact or characteristics. You guys were allowed to use your notes from last night. Um, so you could have either said that it is the y value when x equals 0, or you could have said proportional relationships have a y-intercept or vertical intercept. Oh my gosh, I can't type. Of 0. So the y-intercept or the vertical intercept is the y value when x equals 0. Or you could have also said proportional relationships have a y-intercept of 0. All proportional relationships have a y-intercept of 0. That is part of what makes them proportional. And then for this graph, number 3 asked about this graph over here specifically. What is the vertical intercept of the graph to the right? So you wanted to look and see where this line hits the y-axis. So I can see that it hits the y-axis between 16 and 24. So each of these little squares in between are going up by 4s. So this would be 4, 8, 12, 16, 20, 24, 28, 32. It's skip counting, but in between here is a plus 4. So 16 plus 4 is 20. So the vertical intercept here is 20. What we're going to be talking about tomorrow, I'm going to be giving you guys situations and you're going to have to match it with the graph. You're going to have to know what all of the points on the graph mean. What does the vertical intercept mean for this graph? What does the slope mean for this graph? So this graph here is talking about the cost in a theme park, and it's the number of tickets you purchase and how much it costs. So this 20 here is the starting cost. Your y-intercept is the starting amount. So when you have 0 tickets, automatically it's going to be $20. Obviously, that doesn't make complete sense. If you buy 0 tickets, you don't go to the park, you're not going to pay them. But it's like the starting amount for when they charge you. So they are going to charge you a flat amount of $20 plus a certain amount per ticket. So in this graph here, in this graph over here, the vertical intercept is 20, and that means $20 is the initial fee for the theme park. That is the starting amount that they are going to charge you. Additionally, there is the slope. The slope tells you how much it costs per ticket. This goes up based off the number of tickets you buy. So the slope for this graph, we can see here that it is going up $4. These 2 points here, we're going from 20 up to 24. Let me actually do the little drawing tool. This is going from 20 to 24 here, and then it's going over from 0 to 2. So my vertical, my height, my rise, I went up $4 and went over 2 tickets. So it's $4 for 2 tickets, or an additional $4 for 2 tickets. So that is a slope of 2. 4 divided by 2 is 2. So the slope here is 2. which means it is $2 per ticket in the theme park. So the initial cost is $20 plus $2 per ticket. So for 2 tickets here, you can see that it costs $24. For 8 tickets, it cost $36 because it was 8 times $2 is 16 plus the original 20. So that is what we're going to be looking at tomorrow is we're going to be taking the real world situation and matching it with the graph. If you guys have any questions, please let me know like always, and I will see you tomorrow.